Hello everyone, welcome back to the channel. Today we are going to solve this question called Forever Winter on the Codeforces. So question states that a snowflake is generated from two integers x and y both greater than 1 as follows. Start with one central vertex, connect x new vertices to this central vertex, connect y new vertices to each of these x vertices. So for example, below is the snowflake for x is equal to 5 and y is equal to 3. So x is equal to 5 means to the central vertex you have to join the 5 vertex, and for y is equal to 3 means for each of those joined x vertices you have to add the 3 nodes or the 3 leaves to it. So that is what the procedure is. So this is the description of our snowflake. And given a snowflake graph, determine the values of x and y. So t is the number of test cases, n is upper bounded to 200, and m which is edges, the number of vertices, and m is the edges in the graph, and which is upper bounded by the 1000, right? So why this n into n minus 1 by 2, which is n choose 2, nc2 is equal to n into n minus 2, n minus 1 by 2, which is also the maximum number of edges in any graph possible. In complete graph there are nc2 edges, that's why. So the next m lines each contain two integers, each u and v, the number of vertices connected by an edge. The graph does not contain multiple edges and self loops. So it is guaranteed that this graph is a snowflake for some integers x and y both greater than 1. This point is to be noted, both greater than 1. So yes, graph is given as input in adjacency list format. We can store it in adjacency list format. So what we will do is that, suppose take a look at this snowflake only. What we will do is that we will store the count of the edges, means the degree of the vertex in map. So suppose here degree of this vertex 15 is 1 2 3 4 5, and all these interior nodes which are not root as well as leaves is 1 2 3 4, and the degree of all the leaves is 1. So what I can conclude is that x is the uh, x is when I check the degrees of every vertex, I see that x only appears one times, because see here x is equal to 5, so it appears only one times in whole graph. Okay, degree of only one vertex is x, and dig and all the leaves will have degree as 1, which is their maximum times, and in between the second most frequent degree is y. Okay, this we can infer, and there is one exception to this. Suppose what if x is equal to, suppose this is our central node 1 2 3, x is equal to 3 and y is equal to 2. So it will be like this. So here degree of this central node is also 3, and degree of this internal node is also 3. So we don't know what means the frequencies of degrees will give something like 3 is present some uh, n1 number of times and 1 is present some n2 number of times. Then how do we determine the what is x and what is y? So it is simple. Directly you can see this thing, you can directly say that this is x, and this number n1 minus not n1 minus 1, this number 3 minus 1 is equal to 2 is y. So we can say x is equal to n1 and y is equal to n1 minus 1 if there is only two possible frequencies of the degrees. So that is one edge case. Otherwise this problem is simple. So let us take a look at the code. So here it is. First taking input n comma m, then storing the frequencies in the map, frequencies of the degrees of particular vertex. So PQ, C in PQ, then map, this is kind of funny name, map of P plus plus and map of Q plus plus, means incrementing the degree associated with that vertex with 1, then initializing x and y to some sentinel value, then counting how many times x is present and how many times y is present. How will I do that? I will do that, suppose I will iterate over the every element in map, and if the second number is not 1, see, when the second number will not 1, when that particular node or the vertex in the graph will not be a leaf. So I will assign x is equal to elem dot second, just assigning it. Afterwards I will exchange x and y. The implementation doesn't take into account that x should be x only and y should be y only. I can alter this while outputting my answer. So x is equal to elem dot second, then I'll break, then auto element in map, then I'll count how many times x is present. So it is stored in count of x. Then again for the y, I will again iterate over the map with checking by checking every element, so that element's second part is not 1, means that is not leaf, and element dot second is not equal to x. Not equal to x means we have to just check for y, right? So y is equal to element dot second and break. And suppose if our edge case was there, see this loop, this loop here, this loop here, if it is edge case, suppose x is equal to suppose n1 and y is equal to n1 minus 1, then our y will remain minus 1 only, because every element will be every second part of every element will be 1 or either x, so it will not enter this if statement, if statements block. So y will remain minus 1 only. And finally doing this count of y for y as well. And finally if cx is equal to 1, means x and y are not in the form like this, not in the form like this. Okay, so count of x is equal to 1 means uh, there is only one vertex with the x count of degrees. So this must be the central node, right? So that's why directly outputting x and y minus 1. And else if cy is equal to 1, okay, if you are wondering why y minus 1 here, because here you can see this, we have to check for this edge and not for this edge for counting y, right? Not for this edge. So degree of this vertex will also include this particular edge, means this particular edge. So we don't have to add it to the our answer. So that's why y minus 1. And else if cy is equal to 1, then just alter x and y and you'll get the answer. Else our what is that called, edge case. So directly outputting max of x comma y and leaving a space, then max of x comma y minus 1. So this is our edge case. So that is it. Finally, end of the code. Problem was simple enough. Yeah, so I hope you enjoyed problem solving this problem, also enjoyed the solution and the discussion. So thank you for watching the video. Consider liking the video and subscribing the channel. Hope I see you again on the channel. Till then, keep learning, keep coding. Goodbye.